Welcome to video lecture on differential equations, and today topic is Legendre's linear differential equation. I hope you are all following my video lectures. If you have any queries, just ask me in WhatsApp group or Google Learning group. Okay, and today topic is Legendre's linear equation. Actually, in the last class we learnt about Cauchy-Euler equation. The Legendre differential equation is the extension to the Cauchy-Euler equation. The difference is in the Cauchy-Euler equation, you observe this equation kn into ax plus b whole power n dny by dxn plus kn minus 1 ax plus b whole power n minus 1 into dn minus 1 y by dxn minus 1 plus so on k naught y is equal to q of x. These type of different, here kns are real numbers and q of x is a function of x. This type of differential equation is called Legendre linear differential equation. Okay, the difference between Cauchy-Euler equation and Legendre linear equation is this one. In the Cauchy-Euler equation, here only a power n minus 1 like that terms are there. But in the Legendre equation, instead of a, we have one linear polynomial, that is ax plus b. And the remaining procedure is same for Cauchy-Euler equation as well as Legendre differential equation. Okay. In the Cauchy-Euler equation, what we have assumed? We have assumed x is equal to e power t. Here, instead of x, we are assuming ax plus b is equal to e power t. The remaining everything is same. So here also, what we are going to do? We are going to change the independent variable x into independent variable t. So first we change differential equation into dy by dt format. Again we convert into x. So what we are going to here? Ax plus b is equal to e power t. Then t is equal to ln of ax plus b. Then dt by dx is equal to 1 by ax plus b. And differentiation of ax plus b is a. Here in the Cauchy-Euler equation, it is 1 by x. That's it. By here a by ax plus b. Then dy by dx will be, directly we can't differentiate here. Why? Because y is a function of t and t is a function of x. So dy by dt into dt by dx. Dy by dt same as it is. Dt by dx just now we have found a by ax plus b. So if you cross multiply first term and last term, ax plus b into dy by dx is equal to a dv by dt. So I am writing this one as a d1y, same as it is in the last problem, that is it means in last class what we assume d1 is equal to d by dt. Here I am finding d square y by dx square is equal to d by dx of dy by dx. Dy by dx, I have got 1 a by ax plus b into dy by dt. So if I simplify this one, it becomes a square by, that is 1 by ax plus b differential is a into ax plus b whole square. A into a, it becomes a square. And if you simplify this one totally, it will become a square by ax plus b whole square into d square y by dt square minus dy by dt. So if I get cross multiply, ax plus b whole square into d square y by dt square is equal to a square into, this is d1 square minus d1. So if I get t1 outside, a square into d1 minus 1. Similarly, as like in Cauchy-Euler equation, ax plus b whole cube is equal to d cube y by dx cube. Sorry, this is ax plus b whole cube into, not equal, this is into, that is equal to a cube d1 minus 1 d1 minus 2. The same procedure we have to follow like what we have followed in Cauchy-Euler equation. So we will do some problems. First one, 1 plus x whole square d square y by dx square plus 1 plus x dy by dx plus y is equal to 2 sine of ln 1 plus x. Easily we can identify that it is Legendre linear differential equation. So what is the process? The process is, first we have to assume 1 plus x equal to e power t. So we have assumed here 1 plus x equal to e power t, then t is equal to ln of 1 plus x. Then, and one more thing, d1 is equal to d by dt. So if I change this one into the independent variable of t, then this differential equation becomes d1 into d1 minus 1 plus d1. Here the one luckiest thing is a value is ax plus b. It should be in the form of, but a is 1, so not writing here a square, that means 1 square, even though if I write 1 square will be 1. So d1 into d1 minus 1 plus d1 plus 1 into y 2 sine ln of 1 plus x is equal to t. Why? Because we have to change this one in terms of independent variable t. So if I simplify, d1 square minus d1 plus 1 minus d1 plus d1 gets cancelled. So d1 square plus 1 into y is equal to 2 sine t. The auxiliary equation will be m square plus 1 equal to 0 and m is equal to plus or minus I. This is the imaginary roots. So yc is equal to c1 cos t plus c2 sin t. Again we have to change this t into independent variable x. So yc is equal to c1 cos t is equal to ln of 1 plus x, c2 into sin ln of 1 plus x. Okay. So the yp will be 1 by d square plus 1 into 2 sin t. Here the whenever sin x and cos x functions are there, what we have to substitute? Instead of d, we have to substitute the b minus b square value. Here sin bt means here b is equal to 1. Minus b square means minus 1 square. Minus 1 plus 1, it becomes 0. So the formula what we have, 1 by x square b square sin bx is equal to, that means whenever I substitute x square is equal to minus b square, it becomes 0. The formula we have minus x by 2b cos bx. So 2 is as it is, minus t by 2 into b, that is 1 cos t. So it becomes, instead of t I can write ln of 1 plus x cos t cos of ln of 1 plus x, and y is equal to yc plus yp will give your general solution. And we jump to the next problem. This is the exercise problem, exercise number 65 in your prescribed book, that is differential application of differential equation by Jafar Hassan. So the question is 2x plus 3 whole square d square y by dx square minus 2 into 2x plus 3 dy by dx minus 12y is equal to 6x. The same thing, this is legendary differential equation. So what we have to assume, 2x plus 3 is equal to e power t, that is equal to t is equal to ln of 2x plus 3. So if I change into independent variable t, here 2 square, why? Because here the ax plus b, in here a value is 2. So this is a square into d1 minus 1 minus a into a is 2 and one more 2 is there. 2 into d1 minus 12 into y is equal 6 into x. What is the x here? E power t minus 3 by 2. E power t minus 3 by 2. So I have written here ax plus b whole square into d square y by dx square is equal to a square into d1 minus 1. So if I simplify this one, I will get 4d1 square minus 8d1 minus 12 into y is equal to 6 into x, this one. So the auxiliary equation will be 4m square minus 8m minus 12 equal to 0, and I can factor. So the values are m minus 3 into 4m plus 4 is equal to 0. M minus 3 gives 3. 4m plus 4 is equal to 0 gives m is equal to minus 1. This is our yc. So the roots are minus 1 and 3 in terms of t. So yc is equal to c1 e power minus t plus c2 e power 3. But instead of e power t, what we have assumed, 2x plus 3 is equal to e power t. So e power minus t will be 2x plus 3 whole power minus 1 or 2x plus 3 inverse. C1 2x plus 3 inverse, C2 2x plus 3 whole. So the yp is 1 by 4 into, I have taken 4 outside, d1 square minus 2d1 minus 3, 6 into et minus 3 by 2. Here two terms are there, e power t minus 3. Minus 3 means minus 3 into e power 0 t. So I have splitted into this fraction into two terms. The first term will be 6 by 8, and I have factored this polynomial into two values, that is d plus 1 into d minus 3. The second one also d plus 1 into d minus 3. Here the e power t function is there, in second one e power 0 t function is there. Whenever e power a t, we have to substitute in place of d. Sorry, here it is d1, I have written d. Okay. Instead of d1, we have to substitute a value. It is 1 value. So 1 plus 1, 1 minus 3 minus 3 into 6 by 8. Instead of d1, we have to substitute 0. 0 plus 1, 0 minus 3. So if I simplify, I will get this value. Okay, this is y is equal to yc plus y. Okay. This is Legendre equation, and we have discussed some problems also. Next, miscellaneous differential equations. Okay, that means it doesn't have any formula and all those. Just suppose if we have differential equation of order 2, we have to integration twice to get the solution, either in terms of y or in terms of x. So solve d square y by dx square is equal to x into e power x. So what I am doing here, the differential equation is of order 2, so we'll get two constants. So both sides I am integrating d square y by dx square x e power x. D square y by dx square becomes dy by dx, and x e power x becomes, by applying the integration by parts, x into e power x minus 1 into e power x. So x into e power x minus e, actually here differentiation of x is 1. So minus e power integration e power x, same as it is, plus c1. So again, one more time we are differentiating. Integration dy by dx and integration this total value including constant c1 also. So dy by dx is equal to y only. Here e power x into x minus 1, again you apply integration by parts. So x minus 1 into e power minus x minus differentiation of x minus 1 is 1 minus 0. Integration of e power x is e power x only into dx plus c1 dx. Integration c1 dx value is e c1 x. So y is equal to x minus 1 e power minus x. Here the only one term e power minus x. So integration of e power x is e power x plus c1x and one constant c2. This is the general equation for given differential equation. So here one more problem in miscellaneous. D square y by dx square is equal to 2 into y cube plus y under y is equal to 0, dy by dx equal to 1 when x equal to 0. So this is particular integration, that means we have to find the c1 c2 value also. So to get the easy simplification, what we are doing, multiply by 2 dy by dx both sides. So it becomes 2 dy by dx into d square y by dx square, 4 into, actually one, here already we have 2 and we are multiplying with one more 2, so it becomes 4 into y cube plus y into dy by dx. Both sides I am integrating. See here the term what we are taking 2 outside. Here we are assuming dy by dx is one variable. Then differentiation of dy by dx will be d square y by dx. Suppose you may assume this is t. If I assume this is t, then this term will be dt. So the integration will be, suppose if I assume this term is t into dt, that becomes t square by 2. So here dy by dx 1 by power 1 plus 1 by 2 is equal to here 4y cube plus y dy by dx. The integration value will be 4. Here dx term must be in left side. 4 into y power 4 by 4 plus y integration is y square by 2 plus c1. I have to find the c1 value. Here given, he has given x equal to 0 implies dy by dx equal to 1 and y equal to 0. So I am substituting dy by dx equal to 1 and y equal to 0, it gives c1 is equal to 1. Again we have to find the general solution. So dy by dx equal whole square equal to y power 4 plus 2y square plus 1, which can be written as y square plus 1 whole square. So dy by dx is equal to y square plus 1. So integration on both sides gives, here dy by y square plus 1 gives tan inverse y is equal to x plus c2. Again, we have to find the c2 value by applying x equal to 0, y equal to 0. We'll get c2 equal to 0. So tan inverse y equal to x. So tan y is equal to tan of x. That's all for today. And in the differential equation, we have completed variation of parameters, Cauchy-Euler equation, and Legendre equation, and one more thing I forgot, reduction of order. And tomorrow, that is in the next class, we are going to discuss the partial differentiation. Okay, thank you.